Hello, I hope you're doing fine. So today I'm going to tackle this question that is found on the last year's paper. So this is the November series 2023 paper. So I have decided to just record it directly so that you can see the values that I'm inputting, so that it can be a little bit simplified. So this is Gazigira Steven from Matili Technical. Remember to subscribe to the channel, share, and make more learners get the right knowledge so that they can solve these questions a little bit easier. So I'm going to start. So this is a bearing sheet. This was the first question to be tackled, and this is what I'm going to be discussing. So we have been given the fore bearing and the back bearing. You can observe. So I have written in different coloring in order for you to easily understood. So where I have the blue biro markings, so these are the four bearings. So here we have the four bearings. I have translated that directly. So we have the four bearings here until we finish. Then on the black biro markings, so here are my values of the back bearings. So an example from T, so from T there to T1, we have a fore bearing of 137, 30, 33. Then the back bearing of the same line, that is 317, 30, 42. Then we move to the next from T1 to T2. This is the fore bearing, and the same, this is the back bearing of that line. So the difference between the fore bearing and the back bearing of those lines, that is 180 degrees. Remember that. We have been given here down a table. So the line, so from S to T, then from Y to W. So S to T, this is the back bearing of this line. Then from Y to W, here we have that value. So this is the back bearing of that line. So here we had from W to Y, this is the fore bearing, and then we have been given the back bearing of that line as follows. So we are just going to do we're going to input those values directly from what we have here to, I have already drawn the bearing sheet. Having been given the table below, this is what you're going to be using. So these are the corrected final bearings that we have been given in the question. So ST, this is the final corrected bearing. Then YW, this is the right corrected bearing. But here in our case, we had been given from TS, so we had this 150, 30, 32. So this is the value. So this is the reading from T to S. That is the fore bearing of T to S. So that is my fore bearing from T to S. Point of correction there. So make sure you do that the right way. So from T to S, this is the fore bearing. And then we have been given here, this is 137, 30, 33. This is the fore bearing. Then the back bearing, I have written it in the black pen. So here are all my values. So these are the fore bearings, these are the back bearings of those lines. So from T to T3, this is the fore bearing. Then the back bearing is written in 313, 23, 20. So it is written in the black pen. So remember all these values that I have written here. These are the values that I have directly translated on this bearing sheet. So on our bearing sheet, the first column we have the line, the second we have the observed bearings, then we have the orientation correction, then we have the preliminary, adjusted bearings here, then we have the final correction, then we have the final bearings. So these values I have just translated them from this traverse that I have been given on the question. So this is the traverse that we have been given in the question. So these are the control points. So here we have T, T1, T2, and then we have T3, T4, W, then from W, that is the last station there, then in reference to point Y. So these are the values that I have written here on my bearing sheet. So we have from T to S, that is from this table that we have been given. I want to find my right fore bearing from here, from T to S. So this was the observed bearing, and from this table I will be able to get my correct final bearing that I'm going to input here on this final column, and this is the value that I'm going to have my orientation correction start from. So my orientation correction will be starting from here. So these are the values that I will be using in order for me to get the right answer. So that's where I'm going to start. We're going to use this value. So I have my calculator here, and these are the values that we are going to put on the calculator. So we have 330, that is degree. Then we have 30 minutes and 26 seconds. Then we subtract 180 degrees, because the difference between the fore bearing and the back bearing of this line is 180 degrees. So there I will have my answer as 150, 30, 26. So this is the value that I'm going to write here on this part there. So I'll have this 150, 30, and 26. So that is the value that I'm going to have my orientation correction solved. So here we have the observed bearings, then here we have the final bearing which is correct. That final bearing I have gotten from the back bearing of that line that was given on the provided on the question here by the use of the calculator, and you get the right information there. So I'll have my value here. So that value I will need to find the correction that was applied in order for it to have the final correct bearing here. So by the use of calculator, I'll have my observed value and my final value. The difference between the two will be my orientation correction. So by subtracting this, I'll able to know what was the final orientation correction. So here I had already had my answer there. So my answer, I will subtract my answer from 150, 30, 32. So a correction of negative 0.006 was applied. So that is the correction that I'm going to apply it here on the next station. So that was the error that was corrected on this station. That is the error that is going to be applied on our next station. So we're going to have that value here, because here we had only one correction. That is the value that is going to be applied to the next station. So here we can't divide it by 2, because we were dividing it by 2 on those previous calculations, because we had 2 stations that were providing for us correction. But here in our case, you can observe we have only one station from T to S. So the correction that was to be applied only came from one station. So this is the value that I'm going to apply to the next station there. So there we have a negative 6 on the orientation correction column. So we move on to the next point. So here from T to T1, we had there our 4 bearing of 137, 30, 33. But as we can see, we have a back bearing of 317, 30, 42. So that is the value that I'm going to see if we had an error. So we'll be moving from this value. I'll add 180 degrees, so 137, that was the 4 bearing, 137, 30, 33. So that is the value that I'm going to see if the back bearing of that value is what we have here. You can see the back bearing of that line is 317, 30, 33. But here the observed value we had 317, 30, 42. That means this value was the correct value. So we need to correct what we have observed here in order for it to resemble this value. So we are going to subtract just like how we have done on the observed value and the final bearings. So this was supposed to be our nearly to the final value. So this is 317, 30, 33. So we need to apply a correction of, so we subtract this value to what we have here. So we subtract 317, 30, 42, and we have there our negative 9 seconds. So negative 9 seconds was to be applied here, but we had a correction that was applied before it of negative 6 degrees. So that negative 6 degrees we add with the negative 9 degrees. So I don't think there you'll need a calculator. So that will become negative 15. So negative 15, this is the value that will be corrected. So this is the orientation correction that will be applied on the next station, and that means that is station T2. So again we move, so from T1 to T2, the 4 bearing here we have, so this is 22, 33, 50. We add 180 degrees in order for us to get the back bearing of that line, and that will be 202, 33, 50. But here we can observe our back bearing was 222, 33, 36. That means this value had an error. We need to correct that value to resemble this value on the calculator here. That means we need to find the orientation correction that was applied. So my value here, I subtract that was given to me there, that is 222, 33, 36. So we have a correction of a positive 14 there seconds. So that is the correction that we need to apply on our next value here, where we have T2. But previously we had an orientation correction of negative 15. That means by adding this error of correction to what we have gotten here, that means I will apply, so negative 15 plus positive 14, we don't need a calculator. That means I will apply a correction of negative 1 on my next point. So from T2 to T3, this is the 4 bearing. Here we have 150, so that is 150, 23, 41, then we add 180 degrees in order for us to find our back bearing. There we have 330, 23, 41. But here on our next point, so from T3 to T2, this is the back bearing. So we had an error that we need to correct there. That means I'll take my value found on the calculator, subtract that which we were given in order for me to know the correction that was applied there, and that correction is what I'm going to be using on my next orientation correction. So there we have a correction of 21 minutes. So this is the value that I had added there, so a correction of 21 seconds. So the 21 seconds, that is a positive, so we add that which we had on the previous orientation correction of -1. So if we add that, that means we'll have a correction applied to the next point of positive 20. Simple calculations. So we'll move from that point to the next. That means from T3 to T4, our 4 bearing here we have, that is 200, 225, 16, 35. So here we'll subtract 180 degrees in order for us to get our back bearing, and that will be 45, 16, 35. But here we see the back bearing provided to us on the observation bearing. That means that was 45, 16, 13. So we subtract that to the value here on the calculator. So that is 45, 16, 31. So my answer, so a positive 4 seconds, that is the value that we are going to be having here. So this positive 4, so by subtracting that, we'll apply a positive 4 there in order for me to correct that. That means we'll add that to the previous orientation correction of 20. That means our next correction will be 24. This is the value that will be applied to the next points. That means on our final, so here we have our final control W. So from T4 found here to W, our 4 bearing was 198, 37, 32. So that is the value that I'm going to be having there, and that value is what we are going to be using. So by the use of a calculator, that is 198 degrees, that is 7, that is 7 minutes and 32. We'll subtract 180 degrees, and I'll find my back bearing with that same line should be 18, 37, 32. But here we had observed our back bearing as 18, 37, 37. By subtracting that, I'll have gotten the error and the orientation correction that I will need to have to apply that control point. That means we'll have a correction of -5 seconds. That 5 seconds, we had an orientation correction that was flying of 24 seconds. So 24 seconds minus 5 seconds, they will have a correction of so our correction of 19 seconds. So there, as you can observe, we have only one station. That means we will not have anything there to compare it to. So we'll move directly to the next point. So here we have been given on this corrected final bearing there on the table. So from Y to W, this is 8, 18, 44. So from Y to W, that means this is the back bearing of this line. So and the fore bearing of this line we had been given as 188, 18, 52. So this is the value that I'm going to be using. So I had written it earlier here. So we are going to use the calculator in order for us to find the corrected final bearing of the same line, and that value is going to be gotten from here. So this is the back bearing. I want to find the fore bearing of this line, the corrected final bearing of this line. That means I will take that is 8 degrees 18 minutes and 44 seconds plus 180 degrees. So I'll have my final fore bearing there, the corrected final bearing there of 18, 188, 18, 44, and this is the value that I'm going to write here on this final bearing. So that is 118, 18, 44. So you remember where we have gotten that value from. So I have gotten it from the table there. We come here. So on our next part, we move to the preliminary adjusted bearing found there. So in the preliminary adjusted bearing, that is where I'm going to find my final correction from. So by the use of a calculator, I will go back here. So from W to Y, this is the fore bearing. So I'll have that. So that is 118, 18, 52. Then I will apply that final orientation correction that we had there of negative 19. So that actually is positive. So this is positive 19. That is positive 19 because we had subtracted that value from our previous orientation correction there. So that is positive 19. So you remember that correction there, that is supposed to be a positive 19. So we are going to add that orientation correction to the value that I have taken from the observed. So that is the fore bearing of W to Y. So I'm going to add that final. So you'll have a 0 there and another 0 and then 19 seconds. So my final value there will be 188, 19, 11. So that is the value that I'm going to write here on the preliminary adjusted bearing. So that column there. So my preliminary adjusted bearing, I have gotten it as 188, 19, 11. But my final bearing here was 188, 18, 44. So I will need to know the correction, the final correction that was to be applied here in order for me to have the final corrected value there. So I will use the calculator. I'll use my calculator. So the final bearing. So the difference between these two will be the value that I will have gotten here. I'll come and take my final bearing here. This is 188, 18, 44. So I'll subtract that to this. So I'll have 188, 18, 44. Subtract from my answer. So a correction of negative 27 seconds was applied on this value in order for me. So this is negative 27 seconds. Remember all my values there. So that is the second. From there we come on the final correction here. So I will count my stations. So we have 1, 2, 3, 4, 5, 6. So those are my 6 control stations that were found on this bearing traverse. So we'll have it. So here we'll divide it by 6 stations. So those stations, I've counted them there, remember that. So by dividing my answer by 6, I'll find that I will need to apply a final correction of negative 4.5, and that 4.5 will be increasing in the same correction. That means on my first point here, I will apply a correction of negative. So here we'll have a negative 4.4 seconds. Then it will increase. So negative 4.4 seconds plus negative 4.4 seconds. I will have here my final. So by addition of these two, that means I will apply negative 9 on my next point. So here I'll have negative. So by adding negative 1.45 here, I'll have my negative 13.5 there. Then negative 13.5, adding the same. So plus negative, this is negative 4.5. You'll have negative. So here we add 4.5. This will be negative 18. Negative 18.5. So I'm just adding it. So this will be negative 18.0 there. So when you add here for this 7, so that that is negative 18. Then on our final, so negative 18 plus negative 4.5. So when you add here 4, this will be negative 22.5. So that's how I will have gotten my final corrections there. And these final corrections, we will apply that to the values that I'll have gotten here. So by the use of a calculator, you subtract these observed value here with the orientation correction, and you'll get your answer here. The same is that. So we'll do that for all our values here. Then we'll move on to the next. So these values will use the same knowledge. So by the use of a calculator or just the offset, so I have subtracted. These are my final answer. So where we have an additional, I'll add the second. The same is done to here. Then on our final part, the preliminary adjusted bearings, these values that I have gotten here, and these values are directly from, so the observation minus the orientation, or the observation plus the orientation correction. So use a calculator to do that. And then we move to the next part here. So we'll do the same by the use of a calculator, the preliminary adjusted bearing minus the final correction. So we'll subtract that to all our values until we have the final orientation. So here we have the final bearing. An example, here we have on this first part, so we have 137 degrees, 30 minutes and 27 seconds. I will subtract the value there, so there is negative 4.5 4.5 seconds, and my final answer will be this is 137 there, 137.22.5. so they will round it off, so my final bearing will be 137.30.23 seconds. So the same will be done to this value, and all are my final values. By the use of a calculator, this will be your final answers, and by doing that you will have already completed the traverse bearing sheet. So this is the traverse bearing sheet that is done, so you remember that. So this is the traverse bearing sheet that we are doing. So this is just simply, this was the so this was the November series 2023 traverse. So this is Diploma in Civil Building Architecture. So remember to subscribe to the channel. If you have any question, you can email me at gavigera steven@gmail.com. so this will be all. Thank you for the endurance and revise more on this. Thank you.